So let's talk about the first part first. What are actually Fedora Atomic Desktops? So Fedora Atomic Desktops, you may know Fedora Silverblue, Fedora Kinoite, and the other variants. They are image-based version of Fedora. So they are built from the same packages as the rest of Fedora. It's the same RPMs, no tricks, no changes there. And they packaged into an image and then distributed to systems. So the way this technology works, it's an image-based system. So you get atomic updates. You're sure that the updates are either applied or not applied at all. They are applied in the background. You get background updates. And when you reboot, you get to the new version. If whatever happens, you can always roll back. You can have multiple versions installed at the same time on the same system. And you can pick, when you boot, the one that you want to boot. The nice property with this is that if you know a little bit about Fedora, Fedora approximately has major releases every 6 months. And between that, the releases are considered in stable maintenance mode. And with image-based updates, major Fedora version updates is just like any other update. There's no difference. The updates are applied the same way in the background. You're just switching more packages, more content at the same time, but the experience is the same for users. So it's really powerful in that it really helps us bring users to new version and update systems consistently. So the second part then, what are systemd system extensions? So the general idea with systemd system extensions is they are an image, some form of image, quote unquote, because we will see that there's different way to do it, that you're going to apply, overlay on top of /users. So in image-based systems, usually /user is read-only. It's something that is mounted read-only, different variants, different depending on the systems. And so you cannot just install software on /user. You need something else. And this is where systemd system extension come in. So you've got multiple image formats. The simplest way of doing it is that you can write files into a directory with specific format. And the most advanced way, in a sense, is the DDI, the discoverable disk images, where you can have partition, etc., and a lot of signing, a lot of properties. We'll not look at everything here. We'll focus on EROFS, which is a single naked partition, naked file system image, where you can place the files there and store some metadata as well. You've got the man page, of course, with all the details. So what does a system extension look like in practice? Like you have on your left, you've got your normal system where you would have a set of binaries. And say, for example, you want to debug something that is happening, and on your normal production system, you don't necessarily have GDB installed. So you would bring a Sysexts with GDB, and you would overlay that on your system. And using the systemd sysexts merge command, it will bring this, it will merge this system extension, this Sysexts, with your normal /user and bring you this overlay mount on top of /user and make it look like just as if GDB was part of the image from the beginning, which is really, really nice. It makes like adding tools to the system very convenient, very practical. You don't need any specific container knowledge or anything. It's GDB just like if it would be part of the image by default. So now you might be wondering, why would we ever want to do that with Fedora Atomic Desktops, more specifically? If you know a little bit about Fedora Atomic Desktops, how they're done, we have something called package layering there. So Fedora Atomic Desktop, right now, they are using RPM OS3, and RPM OS3 is an hybrid between a package mode and image mode. So by default, updates are done as image. You update from one version of the system in its entirety. But you can also overlay packages. So you can pick up a few RPMs and change a few of them on the system, replace, install, remove. So you would say, okay, well, if I can do that, why do even bother with Sysexts? Well, the idea is that with Sysexts, this goes much faster. So when you're doing package layering, you have to apply those operations every time on each update because it has to be consistent. Every time you get a new version, you need to redo those operations. With Sysexts, you don't have to do that. You prepare your Sysexts in advance, and you can overlay them directly on your system. You can switch them out dynamically. You can decide to enable ones, remove one, etc. You don't need to rebuild everything all the time. And you can also use non-RPM content. Right now, RPM OS3, it layers packages, so you need an RPM before you can do that. All right, so Then, all right, we said, why do we need all that? Where that's interesting. So let's look at how do we actually make that happen? How do we build the Sysexts for those Fedora systems? I started this project kind of like a little bit more than a year ago, inspired by all the Flatpak work that the Flatpak people were doing for Flatpak Linux. And so right before the last All Systems Go conference, and we started publishing those under GitHub releases, which is a convenient way to ship binaries, in a sense, based on a lot of the ideas from the Flatpak folks around how they build those in GitHub CI. And I've just recently moved it into a different namespace now, so it's not just my personal project. I'm starting to move this into a more neutral place. So what do we have available? If you go there, you will take a look at what the Sysexts that we've actually produced. It's not just me, it's also a contribution from the community. We've got a bunch of things that people are using and find useful at that. So debugging tools, it's like the classical one, it's the first use case. Shells, people want to use different shells than the one that comes by default, which is Bash. The other most common thing is that all the container engines, the virtualization stack, Kubernetes, all those stuff. There's things that you cannot run by definition in containers because you want to use them to run containers. So you have to layer them on your system to be useful. Another more common theme is IDEs. IDEs, usually you need access to either containers as well because you want to run your development environment in containers. So running them in Flatpaks works, kinda, but it's sometimes usually easier to just run them on the host. Browsers is a common theme. Flatpak sandboxing, it brings challenges for the sandbox of browsers. So sometimes people want to run browsers directly on their hosts. VPNs, well, it's usually system-level software. You want to run it on a host as well. Password managers, they need tight integration with browsers. So running them in containers, Flatpaks sometimes doesn't work. Cloud agents, etc., for servers and fonts. So plenty of options here. Okay, how do we actually build those Sysexts? Like, what happens? How do we make this happen? Well, the idea is that if you look at upstream, there's like no special guidance. Like, you do whatever you want as long as it's these image formats. Systemd will take it and will merge it to the system. So that's good. So how do we do it in Fedora? Well, it's an official project right now. It's not an official Fedora project, it's still unofficial. But how do we do this in this project? We use HeroFS images. So we take the RPM that are produced by Fedora. We essentially extract those into a folder. We reset all of the SNX labels so that they are correct. And then we repackage that back into an HeroFS image. And we distribute those HeroFS images. Then the question becomes, okay, we got those things here, but updates happen. We need to update the content. We need new version of all those things. So when do you actually do the updates? Well, how do we do things? Well, the first version was, if I could say, was like building those Sysexts for every single version that we release. So every time we would release a version of the Atomic Desktops or Fedora CoreOS, for example, the CI would go and build all of the Sysexts for those versions. This quickly gets out of hand. Like you get, if you have, I don't remember how many Sysexts we have, but it's about 30 Sysexts, 40. If you're building them for every single version, given that Atomic Desktops, they are built nightly, so every day, the number of Sysexts that you're producing quickly goes out of hand, and so that doesn't really work. We started like that because when you do this, you're sure that the content that you have in your Sysexts, it matches the content that you have on the host. So you can have some form of checks that things are compatible here. But the trick is that most of the time when you have GDB doesn't change that often. So the one you're going to get from this month is going to be the same as next month. So there's no really need into rebuilding GDB all the time for getting the same Sysexts. So then we try and say, okay, what if I just build them when the actual packages in the Sysexts change, which works better. I'm building way less version of the Sysexts. I'm just building the ones that are actually mattering. But the thing is now I have to manage their version because the version of the Sysexts is different from the one of the system. So I have to find some sort of compatibility between like, hey, what version is my Sysexts and what version is my host, and which are they going to work together? And this is where like the troubles start to come, essentially. So you've got multiple options. Essentially, it's the spectrum. Like either you build them like tightly integrated. You've got one version of the system. You build one version of the Sysexts. You rebuild every time. Or you say, hey, I'm not doing that. I want to have the content in my Sysexts be completely independent. So I'm building static binaries and all the stuff. I'm building everything. And so sure, your Sysexts is like completely independent from the host system. And that works as well. Or what we're trying to do is kind of like the last option here, is like we're trying to do something loosely tied. In the sense that if you look at Fedora releases, like in between major versions, generally the glibc is compatible, the libraries are compatible, and so it's less likely that you get something that would break when updates happen. So essentially the idea is that we're versioning per major version. So you would get a Sysexts that are tied to major version of Fedora. So a nice side constraint that is getting in is SLNX. Is that when you're building all of those images, they are layered on top of /user. If you're using Fedora, Fedora is using SLNX. SLNX controls the access of all the files of your system, so you need to make sure that all the files in the Sysexts as well have the right SLNX labels. And so that's like, you have to be careful about that, and it also means that as soon as you make one, you're essentially tying your Sysexts to the SLNX policy that you're using to build those images. So thankfully, most of the time, like the policy isn't changing that much, so it's not a problem. But still, it's like, it's an important bit. The most important thing here is that it's what preventing us from like sharing Sysexts between distributions. So if you look at this, all the work, you say, hey, I'm building one for Fedora Atomic Desktops. Why can't I use the same Sysexts on Flatpak Linux? Well, they have a different SLNX policy. Theirs come from Gentoo, it's slightly different, they have slightly different labels, etc. And so if they take our Sysexts, it's not going to work on their system, and the reverse. So this is like one of the challenges here, in that this strictly ties Sysexts to a policy, and then the policy being distro-specific ties the Sysexts to a specific distro. Okay, so we got a bunch of workarounds to do things. Like the Sysexts, they work kind of well, but there's things that are a little bit mushy on the side. So one of the main things is like, how do you run services from a Sysexts? And I know members in the audience, so I wrote a specific line in the slides. Like I should use portable services, and unfortunately, well, yes, yeah, no, but yeah, these portable services aren't super attractive for us. So we still want to run services from Sysexts. And like right now, when you're booting up, the Sysexts won't get picked up by systemd unless you actually do some of those workarounds, like you use a specific systemd directive to still trigger and have this service be started. So that works, but it's a workaround. Maybe we could do something better. I don't know. We'll see. The other workaround is like, what if the binaries inside of your Sysexts, they need specific users? Say you have, the most common example is the Docker daemon. It needs the Docker user and group. And so you need to have this on your host system when you're merging the system, when you want to start the daemon. Well, you got essentially two options. Either you decide that you want to have things ephemeral, and you have the user groups like set up in the Sysexts decided there. You can use systemd userdb static configs, works great. Or you can go the other road and say, I want this to not be tied, like not be decided in the Sysexts, but actually be a classic sysusers config. And then it would get created per host. But then it means, of course, that the user will persist when you remove the Sysexts. Two options, there's no good or bad, it depends on what you want to do. And finally, a few limits. So what things that don't really work well? The most one, this is like cosmetic a little bit, but like not super practical, is that when you're merging content from different Sysexts, the actual RPM DB of the list of the packages that you have installed in your system, it doesn't get updated because you're not actually installing those packages, right? It's just overlaying on top of /user. But it's pretty nice when you have an image and you can go rpm-qa and you get a list of what it installed. And it would be nice if I could do that as well for the Sysexts and get the RPM QA of each of my Sysexts, for example, or have actually the content from the Sysexts merge into the RPM QA from my host system so that I actually have the full view. Right now, it's not possible, as far as I know, because the RPMDB is a single SQLite file, so we would have to do tricks. Yeah. The second one is, what about kernel modules? Some people have been looking at that, wondering if we could put kernel modules inside of Sysexts. The main trick is that once you do that, there's also a single file here that is that comes into mind, is that the module.dep file with all the module dependency for loading the kernel modules. And same here, it's a single file, so you cannot have multiple Sysexts overwrite this file, otherwise you will only get one updated version. So I don't have solution for that right now. We don't really have kernel module Sysexts because it's tricky, but that's something that could potentially happen if we find a solution for that. And finally, the last one is, how do we actually update all of this stuff? How do we actually keep all of the Sysexts on our system updated? If you look at systemd sysupdate, it works. We can do tricks with systemd sysupdate to make it work, but as soon as we move into the version territory, like where we have Sysexts that are not versioned the same number as our host system, it gets tricky to use with systemd sysupdate. The major one is when we move from Fedora major version, so we move from 42 to 43. Like, you're running on 42 and you want to prepare and download the 43 ones before you actually reboot into it. And you want to prepare them somewhere, but not actually enable them. You only want to get them enabled when you reboot to the new version. And same thing in the other direction. If you rebase into 43, and then for some reason there's a bug in 43 in the kernel, and you need to go back to 42, then you don't want to have the 42 disabled there, etc. And so it gets into this tricky management of which version should I use and enable, and when, and how does sysupdate knows which version to download. And so it's not really, right now it's not there. So to work on all of that, essentially to fix those gaps, I've started a small project, which I very aptly named Sysexts Manager, which would manage the Sysexts for you. So the primary goal here is to work around all those limitations, like being able to download and update the Sysexts dynamically, so that you don't have to care about which version you're running. The Sysexts Manager would look at what is running on your system and figure out the ones that it should enable. Supporting multiple version schemes, so figuring out if you're using one per version or something else. The other nice thing that will be good is that right now there's no constraints on when you can get into Sysexts. And so that's something I would like to add, is adding options to say, I don't want to delete files. For example, I don't want my Sysexts to ever delete files on my system. I want to refuse to merge those. Or I want to make sure that even if I have 10 different Sysexts, they're not going to all 10 overwrite a single file. I want to make sure that they all come with different files. There's no checks right now doing that. And that would be kind of neat. Or making sure that they don't delete or don't overwrite files on the host system. And finally, there's also a thread about SRNX modules here, in that potentially you could have Sysexts that have also their own SRNX modules that you would have to load on your system when you load the Sysexts as well. And the tricky bit here is that you have to actually load the module before you enable the Sysexts. Otherwise, you would have a system where the content from the Sysexts has the wrong labels until you actually load the module into the policy. So that's not great. So the current status of that project, it's still work in progress. I've been working on it on the side. The basics works. You can enable your Sysexts, download them, update them. The link to the repo is here, and I've added a link to the demo here, but I'm a little bit short of time, so I'll let you watch the demo on your board. And that's mostly it. A few links to get you started if you want to join us. Thank you.
Thank you. Questions? Many questions.
Okay, so there is a natural limit what you can update with systemd Sysexts, right? Namely, you cannot update anything in the system which has been used before Sysexts are mounted, right? You can have system extensions for the init ramfs, but they only extend init ramfs. So there was an idea that we can have something like an early system extensions, which would be mounted in init ramfs, but would extend the main system. And for example, with this, you can solve this problem with Linux, because you can bring the update very, very early in the system. You can even update like systemd itself, for example, with a system extension. There is an idea. The question is, do you see it as like an interesting one? And if yes, then we have a feature request for systemd. There, you can go and vouch there.
I would say the focus right now has been things that run late. So the things that run late in the boot process, not replacing systemd so early. So I would say maybe, but I haven't investigated that. We've been focusing more on like, Sysexts that you enable and use much, much later in the boot process.
Is there any way to make images for Sysexts pluggable? Let's say I solved the problem with versioning, with everything. I downloaded my image and placed it somewhere on the file system, and now I want to use part of that to replace part of rootfs, and say that merge that directory with my rootfs directory and come with a new file system.
I'm not sure I fully follow.
In your example, you deliver JDB or you deliver VS Code, you deliver something, right, as an image, and then you mount it on top of rootfs.
Yes.
If I understand properly, right?
Yes.
And most of the problems that you describe it is versioning and how you download and whatever. At Meta, we outsourced that to our own packaging system. We have images downloaded somewhere in a special directory. We don't have a good way to merge that image into rootfs. So, and I thought maybe your project can help us with that, where we can just provide some metadata describing that I have this directory and I want to overlay it on top of root.
That's kind of what Sysexts do already. So I'm not sure I completely follow, but that's like the functionality that Sysexts provide. Ideally, as much as possible, we don't want to reinvent another package managing format, package manager or another format. And
that's exactly what I'm talking about. Decouple mount from package management.
Let's talk maybe after,
okay.
Because I'm not sure I'm getting the whole thing.
Next questions.
Oh, okay. Obviously there is no fine-grained way to express dependencies, like by design. So, like if, for example, I build a Sysext on, say, Fedora GNOME Atomic, and then I try to run it in Fedora Sway Atomic, and it doesn't have lib GNOME whatever. Like, do you run into this problem a lot, or is it not a practical problem?
So I guess the underlying is like, should we have Sysexts that depend on each other? And so
just against the base system. Just against the base system. Like if I build against Fedora GNOME Atomic, then I have libgnome foo already installed, so the system wouldn't have it.
Okay.
And then you try to run it on, let's say, Sway also, which doesn't have that libgnome foo.
Okay, so yeah, that's a good point. Yeah, so there's plenty of tricks that I haven't mentioned in the talk, but like if you can go in how we build them, see how we build them. Essentially, we're trying to build them across a shared base. So I'm looking like for most of those. Building the Sysexts against the Fedora base atomic image, which isn't like an official one, but it's the one that has all the system content minus the desktop, essentially. So when you want to build stuff, you build on top of this one, and so you get the dependencies that are on top of this one. So if you're building the entire desktop into a Sysexts, that's a lot of things. And so moving from desktop to desktop is not going to be pretty. But most of the time, like, you get just enough dependency, but not too much with this trick.
But then this would mean that your Sysexts could have a library which is already in your existing base system, and then you have this collision thing again, right? So it's like pick your poison, yeah.
Yeah, which is the danger, yeah. You would overwrite things that are already in your system.
Do you use convex in combination with Sysexts?
Not yet, not right now. The main problem with convex, kind of, is that they turn /etc into read-only mode. And for a lot of desktop use case, that's not super practical. It probably can be worked around, or...
Then we need to fix the desktops.
Yeah.
Sorry, folks, but we are out of time. We can talk to Timothy later. Let's thank him. Thank you for your talk.
Thank you.